Today we're covering lesson 7.3 and it's titled Multiplication Properties of Exponents. So today we're going to look at a couple different properties and then practice. The first is the product of powers property. This says that the product of two powers with the same base equals that base raised to the sum of the exponent. So here's what it looks like. If you have a to the power of m and a to the power of n, and you are multiplying them together, so a to the m times a to the n, it equals a to the m plus n. In the examples, 6 to the 7th power times 6 to the 9th power, notice the bases are the same. That's 6 to the 16th power. 7 plus 9 is 16. 2 squared times 2 to the 4th would equal 2 to the 6th power. 2 plus 4 is 6. And I'll use that example to kind of break it down for you. So 2 squared is 2 times 2. And you are multiplying that times 2 to the 4th, which is 2 times 2 times 2 times 2. So we look at how many 2's we're multiplying together. You can see there are 6 of them, and that's how we get 2 to the 6th. So let's do some practicing, some simplifying. 5 to the 3rd times 5 to the 6th, that would be 5 to the 9th. And for the purposes of practicing this property, we're going to go ahead and leave it as 5 to the 9th. We're not going to evaluate and write what 5 to the 9th is in a number. Number 2, 3 to the 4th times 7 to the negative 3rd times 3 to the 2nd times 7 to the 6th. Remember in the property on the previous screen, it said that the bases had to be the same. So you're welcome to kind of go ahead and rearrange this a little bit if that helps. I won't do it all the time, but I will show you in this example. Remember that multiplication can be done in any order. So I'm going to go ahead and put the 3's together and the 7's together so that it's a little bit easier to see. So we have 3 to the 4th times 3 squared. That's going to be 3 to the 6th. 4 plus 2 is 6. Then we have 7 to the negative 3rd times 7 to the 6th. When we add negative 3 plus 6, that's 7 to the 3rd power. So 3 to the 6th times 7 to the 3rd. Number 3, we have 2 to the negative 3rd times 2 to the 3rd. So we add negative 3 plus 3, and that's 0. So 2 to the 0. And you can go ahead and write that as 1. Let's incorporate some variables. Q to the 3rd times r squared times q to the 6th times r. So we have the two q's that we need to combine. So that's q to the 9th. And then we have the r's that we're also going to combine. Remember that when a variable or number is written without an exponent, it's an implied 1. So we're adding 2 plus 1 and we're getting r cubed. Q to the 9th, r cubed. In the next example, we have y squared times y to the negative 4th. So we have 3 powers, so they all have y as their base. I'm going to go ahead and write that 1 in there so we can see that. So 2 plus 1 is 3, and 3 plus negative 4 is negative 1. So that's y to the negative 1st. Now, our rules for simplifying expressions say we can't leave negative exponents in our answer, so we do need to go one step further and rewrite it as 1 over y. Remember that in order to make that exponent positive, we move the base down into the bottom to make that exponent a positive 1. I don't have to write the 1 exponent, so I just write 1 over y. You could also write 1 over y to the 1st. The next property is called power to a power property. This means you have a power raised to another power. And what it's going to equal is that base raised to the product of the exponents. So if we have a to the m raised to the n, that would equal a to the m times n. In the examples, 6 to the 7th to the 9th would be 6 to the 63rd, because 7 times 9 is 63. 2 squared raised to the 4th power is 2 to the 8th, because 2 times 4 is 8. And in this one, I'll break it down for you. 2 squared to the 4th power means you have 4 2 squareds. So that's 2 squared times itself 4 times. But each of those 2 squareds is 2 2's. So it's 2 times 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 2. So then you can see how we get 2 to the 8th power. So let's practice. 5 squared to the 4th. That would be 5 to the 8th, similar to the example we just saw with 2. 4 to the 3rd to the 0. 3 times 0 is 0. 4 to the 0 power is 1. And now we've got a little bit of a mess. X to the 4th times x to the 3rd to the negative 5th. There are several methods here, but let's go ahead and take care of this multiplication. Remember that the negative 5 is only being applied to the x to the 3rd. So this becomes x to the 4th times x to the negative 15th. And in our rule from the beginning of the lesson, product of powers, we're going to add those exponents together. 4 plus negative 15 is negative 11, x to the negative 11th. Finally, remembering that you can't leave negative exponents in your answers, 1 over x to the 11th. And then the last property today is power of a product. The previous one was product of powers. This is power of a product. This says if you have a product, that's a multiplication problem, that's raised to a power, it's going to equal the product of each of those factors raised to that same power. So if you have several letters or a coefficient in a parenthesis and are all being raised to the same power, everything in that parenthesis gets that power. So here we see a times b all being raised to the m power. So students, think of it like the distributive property, but please understand this is not the distributive property. But everything inside that parentheses gets that power of m. So a to the m times b to the m. In the example, 2 times 4 all raised to the 3rd. So that's 2 to the 3rd times 4 to the 3rd. Now, those bases are not the same, so we can't add those 3's and say something to the 6th power. But 2 to the 3rd is 8. 4 to the 3rd is 64. If we needed to evaluate, 8 times 64 is 512. In the next example, 4x all being raised to the power of 2. So we're squaring 4 and we're squaring x. 4 squared is 16, so we end up with 16 times x squared. I'll break this one down as well why this works. So this would be if we have 4x raised to the 2nd power, that means we have 4x times 4x. Multiplication can be done in any order. I can rearrange 4 times 4 times x times x. So there you get 16x squared. So let's look at some examples. X to the 3rd, y to the 4th, all raised to the 2nd power. So I'm going to break this one down a little more than I do the rest, just so we can see it. This means we have x to the 3rd being squared times y to the 4th being squared. Now we can go back and use our power to a power rule. We multiply these exponents, 3 times 2, so we get x to the 6th, 4 times 2, and we get y to the 8th. X to the 6th, y to the 8th. Number 10, we have negative 3, x to the 8th, all being squared. So we're squaring negative 3, be careful with your signs, and we are squaring x to the 8th. Negative 3 times negative 3 is 9. X to the 8th to the 2nd, there's your power to a power, that's x to the 16th. We multiply 8 times 2. Remember, as we're simplifying, we don't typically leave numbers with exponents. Anything to the 0 power needs to be evaluated and changed to a 1. We don't ever want repeated variables throughout our answer. We don't want negative exponents. So there's a lot of kind of rules to cleaning some of this up. Number 11, x to the 6th, y to the negative 3rd, all raised to the 2nd power. And I'm going to kind of draw these arrows again, which is why students, think the distributive property. X to the 6th to the 2nd is x to the 12th. We multiply 6 times 2. Y to the negative 3rd to the 2nd is going to be y to the negative 6th. Negative 3 times 2 is negative 6. Then we need to fix this negative exponent, so it's going to go into the denominator. Remember, this actually means we are dividing by y 6 times. So this is x to the 12th over y to the 6th. So I guess I was a little ahead of myself. When we simplify expressions, the steps we take: get rid of negative exponents. Make sure that any bases that are the same only appear one time. You shouldn't have x multiple times in your answer. We want to get rid of any powers that are raised to powers. We want to get rid of any parentheses. And we want to make sure that our coefficients are always reduced. So let's go ahead and do some simplifying. This is the part of this lesson that I really like, these little puzzles that you have to try to simplify or clean up. So we have 3x to the 5th, all being raised to the 3rd power, times 2x squared, all being raised to the 3rd power. So starting with 3x to the 5th, that's 3 to the 3rd, or 3 times 3 times 3. That's 27. X to the 15th, power raised to a power we multiply, times 2 to the 3rd power, that's 2 times 2 times 2, which is 8, x to the 6th. And now we're going to go one step further by cleaning these up, but 27x to the 15th times 8x to the 6th, we do 27 times 8, that's 216. And x to the 15th times x to the 6th, now we are adding exponents. 15 plus 6 is 21. So we get 216x to the 21st. In the next example, we have 4x to the 5th, all being raised to the 3rd power. So 4 to the 3rd, that's 4 times 4 times 4, which is 64. X to the 5th to the 3rd, we had that in the last example, that's x to the 15th. And then we're multiplying it by negative 2, x to the 3rd. Notice nothing out here in the power, but I just want to make sure we see that negative 2. It doesn't really matter where you put the parentheses. You don't even have to put parentheses. I just don't want you to miss that that is a negative 2. So 64 times negative 2 is negative 128. X to the 15th and x to the 3rd, we add those, so that's x to the 18th. Couple more examples here. B squared times b to the 3rd to the negative 2nd. Remember that exponents only apply to what they're immediately attached to. So this negative 2 only applies to the b to the 3rd. So this is b squared times b to the negative 6. My rules say to add these together. That's b to the negative 4th. And now I need to write 1 over b to the 4th to clean up the negative exponent. 15, 6mn all to the 3rd power. Everything is being raised to the 3rd power. If I want to just write it like this first before I try to evaluate, I can do that. Everything's being raised to the 3rd power. They all have exponents of 1. 1 times 3 is 3. Then we're multiplying that by 5 squared, m to the negative 6th. Well, first I'm going to do 6 times 6 times 6 times 25, or 5 times 5. So that's 5,400. That takes care of the 6 to the 3rd and the 5 squared. Now I have m to the 3rd times m to the negative 6. So that's 3 plus negative 6. That's m to the negative 3rd. And then I have n to the 3rd. I don't have anything to do with that one. And again, I can't have negative exponents in my answer, so I clean it up by moving the m to the negative 3rd into the denominator for a final answer of 5,400 n to the 3rd all over m to the 3rd. Remember, moving the exponent down into the denominator will make it positive. Finally, we're going to look at some scientific notation. How do I handle multiplying numbers in scientific notation? And this is actually super simple. We're going to multiply the numbers out in front, and we're going to add exponents. So we're going to multiply 1.5 times 3, and we get 4.5, times 10, negative 2 plus 4 is the 2nd power. 17, 9 times 10 to the negative 6th times 7 times 10 to the negative 9th. So we're going to multiply. 9 times 7 is 63 times 10 to the, we're going to add the exponents, negative 6 plus negative 9 is negative 15. Now remember for our rules, in scientific notation, this number needs to be between 1 and 10. This is too big. So I'm going to rewrite it as 6.3 times 10 to the, remember how we do this? We've made this number smaller, so I need to make my exponent bigger. We've divided by 10, so I need to include multiplying by 10 out here, which means I am going to raise it by 1. Now be careful, those exponents are negative. So adding 1 to negative 15 is negative 14. So we get 6.3 times 10 to the negative 14th. I will check your notes when we come back to class, and we will work on worksheet 7-3.